Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. Hey guys, and welcome to another lesson. In this lesson, we will discuss the graphical method of solving linear programming problems. So the graphical method is simply a method used to solve linear programming problems. And when we say linear programming problems, we are referring to equations or equations and inequalities with linear equations. Okay, so all of our equations and our optimization or our objective function are all linear. Okay, that's why it's called linear programming problems. So in this method, we solve these problems graphically by plotting the constraints on a graph to identify the feasible region and the optimal solution. So the advantage of this method, it is easy to understand, especially for problems with just two decision variables, and gives us or provides geometric insights as it gives us a visual understanding of the problem in order to identify the feasible region. The disadvantage is that it is very limited to only two variables. More than this, it will be much more complicated. So only two decision variables or two unknowns. More than this, it is very difficult to solve using graphical method, and we will start using other methods like simplex methods. Also, it can give us inaccuracy to find the best solutions, especially in the non-linear problems. That's why it is limited to linear equations. Also, it can give us visibility challenges. It struggles with scenarios where the feasible region is unbounded or non-existent, as we will see in one of these examples that we will discuss in this course, making it hard to solve certain types of problems. Now, what are exactly the steps that we are going to follow? So this is an example of how the graphical method works. Number one, we will start formulating the linear programming problem. So for example, if we have sentences that represents our problem, we will convert it into linear equations or equations. For example, we will have objective functions and our constraints. Then we are going to have a graph like XY axis like this one you see here. And on this one, we will plot each equation, each constraint. And then we will find what is the valid side of each constraint line. And what does this mean? It will become more clear in the solved example. Then we will find the feasible solution region, the region at which we will have valid solutions or solutions that satisfy our constraints. Then we will find the optimum point by using the corners of the feasible region or the vertex point of our feasible region. So let's start by having the first example on graphical method in order to understand how does this even work. So suppose that we have this function. We have z equal to 4x plus 5y or z equal 4x plus 5y. And this one or this objective function consisting of two decision variables x and y. We would like to maximize this function. We would like to find x and y that maximize z. So this equation is subjected to some constraints. These constraints are mathematically formulated like follows or as follows: x plus y less than or equal 20, 3x plus 4y less than or equal 72, x and y greater than or equal 0. So how are we going to solve our problem? So as we learned before, number one, we will need, if we get back here, number one, we need to formulate the linear programming problem. and then we will construct a graph and plot the constraints line. So if you can see here that number one, we already have our formulation. We have this one, which representing our objective function z equal to 4x plus 5y, and we have some constraints. The first step is that you will convert each constraint into or inequality to equality. So we have x plus y less than or equal to 20, so it will be x plus y equal to 20. This one, 3x plus 4y less than or equal 72. We will make this inequality becomes equality, so it will be 3x plus 4y equal to 72. Okay, and finally x and y greater than or equal to 0. We will translate this in the end. Okay, so number one, we converted inequality to equality. Okay, so we have how many equations? We have 1 and 2, equation 1 and equation 2 representing our constraints. Okay, now what I'm going to do, number one, or the next step is plotting these constraints. So we will plot x plus y equal 20 and 3x plus 4y equals 72. So I'm going to do this. So for the first constraint, x plus y equal to 20, this one, which is this one, first constraint. So I would like to draw, so we have our axes like this, x and y, and I would like to plot this equation, x plus y equal to 20. How I'm going to do this? Simply x plus y equal to 20. I will start by, let's say, x equal to 0, like this, and substitute it here. I'll choose any value. For simplicity, I usually use 0 values, okay? So we will assume x equal to 0. Then what is the value of y? Y will be equal to 20, right? So the first point that satisfies this equation is 0 and 20. Again, I'm going to do this for y. Now let's say y equal to 0. Okay, if I substitute with y equals 0 in this equation, then x will be 20, right? Like this. So our second value, 20 and 0. Okay, so we have 2 points like this. So we have 0 for x and it will be 20 for y. So 0x, then 20y. That is the first point, this point, okay? Like this. Second point, x equal 20 and y equal to 0. X equal 20, like here, and value of y is equal to 0. Then I will connect this together. So I draw the first constraint, like this. So as you can see, first I set y equals 0, x becomes 20 by substituting the equation. So we'll have first point and also x equal to 0 to get y and the second point. Now, as you can see, if we plot this figure, it will be like this, just as I explained right now. Now, that is the first line or the first constraint. I'm going to do the same step for the second constraint. So in the second constraint, we have 3x plus 4y equal to 72 or less than or equal 72. I will convert it into equality, 3x plus 4y equal to 72. First, I will substitute with x equal to 0, find value of y, okay? Then substitute with y equal to 0 and find value of x, okay? To get 2 points, 0 and here 0, like this. So when I substitute with x equal to 0, it will be y equal to 72 over 4, okay? 72 over 4. When I substitute with y equal to 0, then 3x will be 72, so it will be 72 over 3. So as you can see here, I already did this. When y equal to 0, then x will be 72 over 3, which is 72 over 3 is equal to 24. So the first point here will be 24. 24 and 0. Now similarly for 72 over 4, okay, so as you can see here, 74y equals 72, so it will give us 18. So this second point will be 18. Okay, so we have 2 points that satisfy this equation or this equality. Okay, so we have these 2 points. Now let's delete this. Now if we plot this, the first point is x equal to 0 and y equal to 18. So x equal to 0, go up, y equal to 18. So that is the first point. Second point is x equal to 24 and y equal 0. So go all the way here, x equal to 24 and y equal to 0. Okay, then we connected the 2 lines together. Finally, we'll find that we have x and y greater than or equal to 0. What does this even mean? By logic, x and y greater than 0, it means that we are working in the first quadrant, right? So we have here like this. If we draw it, x, y, x and y, here x is positive value and y equal positive value. So both of them are positive in this first quadrant. X positive and y positive, right? Okay, so it means that we are working in this first quadrant. Okay, what is the next step? Next step, I am going to combine these 2 graphs. So we have the first constraint, second constraint. Of course, I'm plotting them on the same figure. Here I'm showing you each one individually in order to understand the idea. So when I'm going to draw it both together, I will have this graph, right? This is the first constraint and second constraint. Okay, great. Now what? Now I'm looking for something which we call feasible region, the region which satisfies these constraints. So number 1, x, y greater than 0, it is the first quadrant as I just explained. X plus y less than 20. So we are talking about this one, this line. Now the question is, if I get back here, the question is x plus y less than or equal to 20, right? So my question, I am talking about this one, this line representing x plus y equal to 20, right? I am looking for less than or equal to 20. So where is exactly less than? So is it in the side? Is this side x plus y less than 20? Or this side x plus y less than 20? So you can see that this line goes to infinity like this. It divides the graph into 2 regions, this region or this side and this side. Which one satisfies x plus y less than 20? How can I do this? Just substitute any point above or below and see if it's satisfied or not. So for example, if I selected this point, which is 0 and 0, right? If I substitute this point here, 0 plus 0 less than 20. Is it satisfied? Yes, it is satisfied. 0 less than 20. Okay, so what does this mean? It means that this side is the one which I'm working with, this side. This side is wrong. Now, another way is that, let's say, for example, I selected this point. Let's say this point is 21. 0x and 21y. If I substitute it here, it will be 0 plus 21 less than or equal 20, right? So it will be 21 less than 20. Is that correct? No, this is completely wrong. So it means that this point is not satisfying this equation. So it means that this side is wrong. So it means that this is the side I'm working with. So for this equation, the one which satisfies is this region. Okay, since we are working in first quadrant, x and y is positive, and this is the side here that's satisfying the equation. Okay, what about the second one? Similarly as before, the second equation is 3x plus 4y less than or equal 27. So the second equation, 3x plus 4y less than or equal 72. This one is 3x plus 4y equal to 72. Now, as you can see, it divides the graph into two regions, this region and this region. Which one satisfy? Again, I will substitute with this point, 0 and 0. So we'll find that 0x plus 4, 0, less than or equal to 72. 0 plus 0 less than or equal to 72. So it satisfies. It means that this is the region which satisfies the equation, this one. Okay. Now, when we combine them together, so we will have this part and this one, this part. Now, as you can see, this part here satisfy the green one, but does not satisfy this one, right? Any region is downward here or this side. So this one is out, is not a feasible region. It does not satisfy the two constraints. This one, this region here, satisfy the red one. However, it doesn't satisfy the green one. The green one, this side here. Okay, this side is out of the constraint or out of the, does not satisfy the green one. So it means that this one is also out of boundaries. Now what you will see is that this region here, all of this region is the one which satisfies both of the constraints, this line and the other one here, right? In addition to x and y greater than 0. That's why this is a final equation or the final region. You will see that this purple one or violet one, purple or violet, this one here is our feasible region, the region that satisfies these constraints. Okay, it means that our optimal solution will be found in this region. Okay, now how can we do this in the graphical method? We look for the corner points. What I mean by corner points, you can see that this shape here, which you can see, has some corner points. We have this point 0 and 0, we have this point 20 and 0, we have this point which is 0 and 18, and we have this point which is the intersection of the two lines, right? Intersection of x plus y equal to 20 and 3x plus 4y equal to 72, right? So in graphical method, we look for the vertex of the feasible regions or vertices of the feasible region. One of these will be our optimal solution. So the final point which we need is number C. How can I do this? By solving these two equations. So the intersection of these 2 points by solving x plus y equal to 20 and 3x plus 4y equal to 72. By solving these two equations using calculator or any other method, you will find that x will be equal to 8 and y equal to 12, or our point C is 8 for x and 12 for y. So this point will be 8 and 12. Great, so we have our 4 points here. Now what? Now you can see 0 and 0, 0, 18, 20 and 0, and 8 and 12. One of these points is the optimal solution. How can I get it? We would like to do what? We would like to maximize maximize this function. So in each point we have value of x and y. I will substitute with them here and find the maximum value. So we will substitute these corner points, points, and we will find the maximum one. So our objective function z equal to 4x plus 5y. So by substituting 0 and 0, 20 and 0, 0 and 18, and 8 and 12. 0 and 0 gives us 0, 20 and 0 gives us 80, 0 and 18 here gives us 90, 8 and 12 give us 92. So as you can see that this point gives us the maximum value of the objective function. So what does this mean? It means that our maximum value is z or z equal to 92 and the corner or the corner point or the point or value of x and y which satisfy this maximum value is that x equal 8 and y equal to 12. Great, I hope you now understand how can we apply the graphical method in order to solve any 2D or two decision variables equation, linear equations. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You will find also in this academy, you will find the different feedbacks from some of our students that joined our courses. You can, for example, join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits, you will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics. Okay, and you will find that inside, when you join this membership, you will find this blueprint that will guide you in which classes you will start with when you join this membership. So thank you and see you in our membership on Khadija Academy.